All right, so today we're going to look at specific types of quadrilaterals. We're going to talk about properties of parallelograms and rectangles. So first off, a quadrilateral is a four-sided polygon. So we talked about that a little bit with different names of polygons. So today we're going to look at different specific types of quads. And when you're naming a polygon, you are going to be starting at one vertex and then going around the shape. It does not matter in which order you go. So if I drew a four-sided quad and I labeled this would be quad, and then I would pick a point. Doesn't matter if I said I wanted to start at C, then I would just have to go in either direction. If I went around this direction, then it would be quadrilateral C, B, A, D. You just have to go around in a continuous order. When we have a specific type of quadrilateral in which both pairs of the opposite sides are parallel, so that would mean the top and the bottom would be marked parallel, in addition to the left and the right being marked parallel, that would be a parallelogram. And then these are all of the different types of types of quadrilaterals that we're going to talk about. So we've looked at a quad just being four sides. Today we're going to focus on parallelogram and then rectangle. So rectangle is going to be a more specific type of parallelogram, and then we'll flow through this chart and finish off the other shapes later on. So if I say that it is a parallelogram, then what are the things that must be true? So first off, what we had just said, that both pairs of opposite sides are parallel. Another property, not only are these opposite sides going to be parallel, but they are going to be congruent to each other. So both pairs of opposite sides would be congruent. Also, both pairs of opposite angles would also be congruent. One more with the angles. That would mean that the consecutive angles, so two angles that are in a row, are going to be supplementary. And then the last property with a parallelogram, if I draw in the diagonals, the diagonals split each other in half, which means the diagonals bisect each other. So then we can apply these properties. So first off, if I look at BCD, so this angle here is 125 degrees, and I want to know then what is the measure of BAD, which is the angle opposite, and opposite angles in a parallelogram are congruent. So 125 degrees. For the next one, it says that AB is 5x minus 3 and CD is 2x plus 9. These are opposite sides, and in a parallelogram, opposite sides are equal. So I would set these two sides equal to each other. And then solve. I would get x equals 4. And since I'm finding AB, I would plug it back in for AB, which is 5 times x minus 3. So AB is 17. Last example here with a parallelogram for this one is looking at ABC, which is 50 degrees. And it wants to know the measure of BCD, which is a consecutive angle. It's the very next angle. So consecutive angles are supplementary. Supplementary to 50 is 130 degrees. Next one is looking at parallelogram RSTV. Remember, when I'm naming it, I go around. So I'll just pick a starting spot for R, and then go around S, T, and then V. It says the diagonals, when I draw them, are RT and SV. They intersect at point Q. Then it says to label RQ 5x plus 1. And then it says QT is 3x plus 15. These are parts of the same diagonal. In a parallelogram, diagonals bisect each other, which means these two parts must be equal to each other. So I can solve this one and get 2x equals 14, so x equals 7. When I'm finding the measure then of QT, it is 3x plus 15, plugging in my 7. 21 and 15, I would get that QT is 36. The last shape we're going to look at today is a rectangle. First thing that we need to remember about a rectangle is that it comes directly from a parallelogram. So we're going to have all of the properties of a parallelogram and then 2 more. So we're going to keep all 5 of these properties here for a rectangle, because a rectangle comes directly from a parallelogram. But then we're going to add 2 properties. In a rectangle, all angles are right angles. And then also, not only do the diagonals bisect each other like in a parallelogram, but also they are congruent, which means all of those parts are equal. So diagonals are congruent. So we can apply these 2 properties for rectangle problems. It says AC is 4x minus 60, and BD is 30 minus x. Those are both diagonals, and diagonals are equal to each other. So I'm going to set 4x minus 60 equal to 30 minus x, which is going to give me 5x equals 90. Divide by 5, and I get x equals 18, but I need to make sure I answer the question of find BD, which is 30 minus x, which means BD equals 12. For number 2, we're going to use the same diagram. In this case, it says that the whole diagonal is 4x minus 60. And then it says AE, which is just this little part of the diagonal, is x plus 5. Because diagonals bisect each other, if AE is x plus 5, then EC must also be x plus 5. So I can add those two together and set it equal to the whole thing. And solve. And I get x equals 35. It says find the measure of EC, which is x plus 5. So EC equals 40. Says for this one, BAC, this angle right here, is 4x plus 5. And CAD is 5x minus 14. Those two angles together form the right angle. All angles have to be right angles in a rectangle. So when I add those together, I get 90. So I get x is 11, and then I need to find the measure of CAD, which is 5x minus 14. So 5 times 11 minus 14. And I get that it equals 41 degrees. Can use the same diagram, so I'm going to erase some of this for number 4. Says that AE is 2x plus 3, and BE is 12 minus x. Remembering the diagonals are all congruent and bisect each other. That means all 4 of those broken up parts of the diagonals are equal. So 2x plus 3 has to equal 12 minus x. So I get x equals 3, and then in order to find BD, when I plug 3 in, each of these parts are going to be 9, which means the whole diagonal is 9 and 9, which is 18. And then lastly for number 5, so this is 18. If I plug in BAC is 3x plus 5, and ACD is 40 minus 2x. Remembering from an earlier chapter, those are alternate interior angles from my parallel lines, which makes them equal to each other. So I get x equals 7. Plug 7 in, and I'm going to get 26. So I get 26 degrees here. And that means because of all of those segments, all of these little angles are 26. And because I know this entire angle is a right angle, I can subtract 26 from 90, and I can get 64 degrees for all of those other little ones. And then in order to find the measure of AED, I have a triangle, and I can subtract 64 twice from 180 and get 52 degrees. And that is it. We will look at the other shapes later on in this chapter.